Hello and welcome to another episode of the Oxford Online Maths Club. My name's James and today I'm joined by Sophie.
Hello.
Sophie is a PhD student in London at the
Yep.
moment, and I know Sophie from a variety of different things. Sophie is on the stream today to tell us about some maths.
Yes. Though I think we should probably mention where we first met,
Oh gosh, I was
James.
trying to remember as I did that where we first met. I think I know. Um,
So we first met when I was an undergraduate student in Cambridge, and James was my supervisor, and I think I might have been in my first year, or maybe
Gosh,
second. It was a course like vector calculus or fluid dynamics or something.
one course only probably. If you're
Yeah,
a
it was
first
only
year.
one
Wow.
course that you supervised me for, but
Well,
back
here
when
we
I
are now, both of us in Oxford, or me in Oxford and you on the Oxford live stream. Aya recognises you as well. So Aya in chat wins the prize for being the first person to recognise Sophie from Number File.
Yes.
How
Yes,
many?
this is true. I have also been on number file a couple of times.
It's more than a couple of times, right?
By a couple, I mean three, which dictionary definition, three does actually count as a couple by the dictionary. But I'm sure most mathematicians here would dispute that three is a couple.
Mm. Okay, okay. I've done a poll because we always like to check with the audience how their day's been. There's a poll in chat. If you would like to join chat, if you're watching for the first time perhaps, you can join chat at slido.com/OOMC, which is where we're based. You can be anonymous on Slido chat, and you can ask us anything about the maths that's going on during the live stream live. Um, Sophie, how's your day going on a scale from 1 to 5?
One to five. Let's go for a three, I think, which
Ooh,
is
only a 3. Okay, middle of the road. That's not great.
yeah, well, it's quite rainy, and because it's been quite rainy, I've not really been outside today, so I definitely should try and go outside at some point.
The rain for me was quite a sort of bonding experience. It started absolutely hammering it down out of nowhere, um,
Hmm.
while a group of people, none of us knew each other, all about 10 metres away from the front door. So we had a little 10-metre dash. Great,
Hmm.
great team building activity. Would recommend. People
Nice.
are talking about exams. Is it exam season somehow?
Uh, I suppose for some schools they've just come back after half term, so it might be when some schools try to do mocks.
Yeah,
Uh,
and I guess maybe there's international A levels happening at the moment. Somebody's had a chemistry exam. Um, they want to know when UCAS is going live. They're very excited about that sort of thing. I think UCAS is going live in September, so not for
Um,
ages.
it
Um,
depends. So I actually do know this because I spent a year working for a university in their recruitment.
oh,
So you can set up your UCAS in the summer, but you can't start applying to the universities until the autumn.
that's it. Okay. Well, then maybe they're talking about if they've got offers and they want to know, oh, well, UCAS load wants to get my results.
Oh, this will be the people who are in, I guess, their final year of school.
Yeah.
Um, so depending on the university, some will have got offers. Potentially if, oh, will UCAS load once I got my results in May?
That's the question.
Um, I guess if you're on a different system, it might be different because particularly if you're not getting A levels, UCAS might not automatically get your results. I think that would be one thing you'd have to discuss with your teachers and UCAS, who know the ins and outs of the specific qualifications you're doing.
Yeah, talk to the universities you've got offers from. I'm not saying anything because I've got a suspicion that the way that international A levels works might have changed this year. But I know I've got an email in my inbox somewhere.
Yep.
Um, right, okay. Kevin wants to know if they can ask about maths courses at Oxford. Yes, you can, but I'm also going to point you towards our open days, which are 20th of April, 27th of April, and we're doing one in-person one in Oxford, for which bookings required because we have a pretty strict requirement capacity limit, and we have one online open day, which is going to be sort of live streams and pre-recorded math stuff the following Saturday. Those are our 2024 open day dates. There are also a bunch of university open days where all of the departments and all of the colleges are open and people can wander around and visit absolutely everything that's going on in Oxford. Those are later on in June and September. But the Maths Institute likes to get in first with some specific departmental ones. It's a whole day of activities in Oxford. The online one, uh, just the morning and then some pre-recorded things.
I will say with colleges as well, if you're at an open day and you want to look around a college, a lot of colleges are very nice if you say you're a prospective student and will let you look around.
Yeah. If anybody's in Oxford and you're thinking about visiting colleges and you see a sign that says no visitors, you should still ask.
It's always worst that can happen is they say no. I've had it before. So I wasn't at Oxford, I was at Cambridge, but I've seen some people looking lost outside of college, and I've pretended that they were my cousins and shown them round
Wow.
to get them in.
What a service! Cousins, right? Amazing.
Yeah, I had a lot of cousins.
I've definitely seen some of my students, like current students, at the open day, just wandering around trying to get free stuff, like because they still look young enough to be prospective applicants. Anyway, somebody asks if we're going to be at any offer holder days. I'm not at any of the offer holder days off the top of my head, not that I know of. If you've got an offer holder day coming up, brilliant stuff. That sounds really fun. I'm also going to plug the summer school again. Can I plug the summer school again? There's a summer school called Promise Europe. Applications are still open. They set hard problems as their application process. Even if you're not applying to Promise Europe, you might like the hard problems that they've set. And hey, if you're age 16 plus, pre-university, and from somewhere in quite loosely defined Europe, yes, including the UK, then hey, there's also a summer school that's linked to those questions. I don't know about the Oxford AI Society, Kevin. I'm going to try and look up the Oxford AI Society event. If it's a conference that you need to sign up for, check their website to see if you can. I'm going to try and look it up as well. But I need to set up Sophie, because so you've got a plan for some maths that we're going to do today, right?
Yes.
I put colour by numbers as the title on the video.
Yeah. Because it basically comes down to when I was studying at for my undergraduate degree, an argument I got into with a friend, because I would kind of get to lectures and get out like my blue pen and then my red pen and my green pen, and some other people, specifically I will say the men, did not do this, and when I said it makes it significantly easier, particularly when drawing graphs and things, to be able to have different coloured lines, I got the response, oh, but I can just use black and blue. And I said, what if you need 3 different colours? And they said, I'll use a dotted line, which I thought was horrific. And also, kind of one of my like big tenets of life is if you can make your life easier by doing something simple, then do it. So I partly just collected evidence as to why I was right. But I think there are also a lot of maths that can be quite colourful and could be quite fun. So I wanted to share some of that with you today, James. So the first thing some people might have heard of, so if you don't spoil it in the chat, but hopefully we can talk a bit more about why this is true. Because we're going to look at a map, and actually I have some example maps on the second slide I sent you there, James.
Right, yes, this is how we're running this. I can show the slides like this.
Well, I could have asked you to draw out an accurate map of the UK for me, James.
Yeah, we had a chat about my art skills pre-live stream, and people who have watched before know that my art skills do not extend to an accurate map of the UK marking. Are those all of the counties of the UK?
Yes, they are. There's a comment saying I'm colourblind. Doesn't mean I can't major in maths. I'm guessing this is probably a joke. But also, when I say colour, the great thing about this is you don't even need to have different colours. A, you can choose colours that you can see. But B, you can label them. You can write the word blue. Or even use numbers. Often in maths, colours then become numbers when you're just labelling things with colours. So it doesn't matter anyway. So, you know when I said don't spoil it, just notice this in the chat. Don't spoil it.
Chat's very enthusiastic on this sort of thing.
But, yeah, the question is, how many colours do we need to colour the map if we're saying adjacent sections can't be the same colour? Okay. So, firstly, James, I want to check, what do I mean by adjacent? Because I think you can define adjacent in a few different ways. So we've got to make sure we're all defining it the same way.
I think adjacent means they kind of share an edge, but then I'm going to have to say what I mean by edge or something. I'm looking at this bit. Is my cursor on the screen? I can never remember. Let's assume it isn't. I'm looking at the kind of wiggly boundaries between these things.
Isn't that Dumfries and Galloway, and then whatever the county below West Lothian is?
Oh no, an art test and a geography test. I did not revise. Okay. Notwithstanding what these are, I think adjacent is going to mean ones that are touching.
Yep. So with this, there are two things I want to be specific about. I would say it's sharing all or part of an edge. So if they touch at a corner, I wouldn't count that as being adjacent if it's only a corner.
Okay.
I suppose their shared border has to be of length greater than 0.
So now I'm looking for corner sharing on the map. I'm not sure.
Oh,
okay, hang on.
Down the bottom there.
Just west of London. There's a four county points down there.
Yes. Yeah. So there are a few where I think if you go south of London as well, there are a couple that look like they might touch. They wouldn't be considered adjacent.
Okay. If they're the four quadrants of XY space, then
exactly.
It doesn't matter.
Exactly. So the question is, how many colours do we need to colour in this map with that rule?
Yeah. Chat is, I think it's fair to say, well ahead of us. Imo says it's 165,813, so no, not really. Chat says, including Imo, sorry to single you out.
So,
4.
Yes, the chat is right in saying 4, but the chat has not picked up on some of the details. Because for these maps, 4 is enough, and actually these maps do require 4. It's all very well knowing it's the 4 colour theorem. Some maps do not need 4 colours. In fact, Australia doesn't need 4 colours if you don't insist on colouring in the sea.
Ooh.
So
this is Australia on the left. I can do that much geography. And you think you can... You're telling me that we can 3 colour Australia? The territories
if
of
we
Australia.
don't count the sea. The sea makes it into 4 colours. But otherwise, if you're just looking at mainland Australia, that can be done in 3.
Who else is watching at home and 3 colouring it in their heads? There's 3 on the left that all have to be different, and then I guess... Wait, hang on. It's like a... I can't think of anything that's like that, but there's a bottom one. I've realised its shape. There's a bottom one.
Like a rainbow horseshoe shape.
Yeah, but I want the stripes going the other way to a rainbow. I almost said rainbow, but rainbows unfortunately have got the stripes going the wrong way for what I want, which is striped outwards. I guess you can do that like a life ring, but with lots.
Yes.
Australia needs 3. Excellent shout out to /r/maps without New Zealand in chat. Great stuff. New Zealand though doesn't share any land boundaries with Australia, so I guess that's a nice thing. It means that it doesn't. If you can 3 colour New Zealand and you can 3 colour Australia separately, then you can 3 colour the combination.
Yes.
Just make sure you use the same colour palette for each of them.
Yeah, that would be an easy and annoying way to slip up on that one.
Okay, I guess the naive thing to say is, well, then you can 6 colour it because you've got your 3 colours on New Zealand, your 3 colours on Australia, and this is really obvious, but use the same 3 colours. And chat's trying to extend.
Chat has actually though come up with an interesting point that I was going to move on to. That someone has said it's not just 2D maps, it's also spherical maps. This is true, but what it isn't is maps with a hole in it. So if you had a donut and drew a map on the donut, you might need more colours for that.
I'm trying to alt-tab into a picture of a donut. I have lost everything though. Oh my goodness. Help chat, help. No, I can't find out where I'm alt-tabbing to. I'm coming back. Where's my Miro board gone? I was going to try and draw a donut map. Does chat know the answer on a donut? I'd be really interested if chat has already heard of colouring in maps on a donut.
Just passes the time, You're having your donut and...
You think, what if I drew some countries on here and they shared some borders? You can colour them in. if you haven't seen the problem before, I think maybe that's a good intro to why I find the four-color map theorem surprising. Maybe my
Yeah,
first guess is that it's something to do with the number of countries, right? Like,
sure.
or counties or whatever we're shading here. Maybe it's that many. And if it's like the birthday paradox, then I'm super surprised when it turns out to be the square root of the number of countries. But no, the answer is just flatly 4. Yeah, and people have mentioned islands, and then someone else in chat, I love this, has answered to say the islands can be one-coloured, so that's fine. You do them separately,
Yep.
choose the same colour for all the islands or something. I love it when chat poses a question and then also answers it. You know, maybe it's the same anonymous person, but...
That posing your own question so you can answer it. But yeah, do you want to know how many colours in a torus?
I think I do. Nobody in chat's told me yet, so I think I need you to tell me.
It's 7.
7.
Yeah, which is also one of those things that it doesn't feel like there's a pattern. If I said 8, you'd be like, yeah, there's probably something going on there.
Twice as many. 1 for the front bit, 4 for the back bit.
But 7's there.
No, 7. So you're telling me there's a map. There's 2 things in there. Firstly, that you can always do it with 7 colours.
Yeah.
And secondly, that there is some bizarre map on a torus donut shape that needs 7 colours.
Yeah. That's a challenge for you to try and come up with it. I can't think off the top of my head one that needs 7 colours, but it exists.
I think I should just say neither can I and move on. Something with hexagons. Hexagons are good.
Hexagons might be good actually, send them around.
You can maybe put a bit of hexagonal grid on here and then make it all join up around the edges so that the opposite ones are all touching each other. Yeah, it's probably this.
Yeah.
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 Put a hexagon in. Live maths. Put a hexagon in. Put pieces on the side, join them all up round the back. I don't know.
Yeah. I mean, the thing is, because you don't even necessarily need them to all be touching each other. There are maps that require, for the flat 4-colour theorem, there are existing maps that need 4 colours, but it's not just that there are 4 regions that all touch each other. You can have like weird linky chain things where this means that this has to be this colour, that means that has to be that colour, and then you get stuck at some point.
Oh, wow. Oh. No, what? Okay, right, because you could have a cluster of 3 that force you to use 3 colours for that bit. And then the obvious one that I'm thinking of is a 4th country, like, round the outside of those 3. That has to be a 4th colour. That proves you need 4 colours. But maybe there's... So hang on, this kind of map. Pie chart, exactly. And then one slightly aggressive country that's formed its territory all the way around the other 3.
So I like to actually think of this one the other way as well, with the other one, an inner country, like an enclave, as opposed to, because actually, if you do it this way, this helps you to show a bit about how mathematicians prove the 4-colour theorem.
Ooh, okay.
As well as it being a good example. So, we got some hideous yellow. Nice.
Yep. Art skills stream.
Yep.
My PowerPoint's also frozen. PowerPoint didn't like that shade of yellow at all.
But if you consider this map, and suppose we can do it, let's take away that enclave.
Okay.
So we've got a kind of thirds in a circle. And there could be whatever's going on around the outside of it, right? But we can know if we can do it with whatever's going on the outside without that enclave, we can put the enclave back in, and that can be whatever colour we haven't used.
Oh, okay. So you could kind of, if you've got a little enclave like that, you could briefly consider deleting it, which maybe simplifies your problem. I'm always interested in ways to simplify problems.
Yeah, exactly. You just kind of delete it, because you know that if you can do it without the enclave, then you can do it with the enclave. So you don't need to check both. And actually, what this does, there are more complicated configurations like this. But this means that the number of possible maps becomes finite.
That's not obvious at all, is it?
It's not at
But
all obvious.
not obvious
Um,
and true. The best sort of maths.
yeah, I mean, it took mathematicians genuinely years. I think between 1950, they maybe worked out that there were 10,000 things they had to check, and it took them about 20 years to get that down to 2,000.
Okay, and these things to check are combinations with more than four countries, I guess.
Yeah, these are
Um,
like huge maps in some cases. I mean, there will be some that are small, but it's just all possible. Someone said how small is finite? It depends. Finite in 1950 was 10,000 or so. Um, Finite in 1970, I want to say, was then more like 2,000. Finite in 1976 was 1,936. So we're talking in the thousands,
yeah, but
that kind
it's.
of order of magnitude. Still big numbers, but
I'm really sorry if anybody
more
can
to
hear the
access.
hammering that's just started in the background for me. I think I'm going to try and mute myself quite a bit. Proof by exhaustion, but lots of things to check. Yes, but that's better than checking kind of infinitely many things one at a time. Um,
Yeah,
Sort of wish they'd released the when you get it down to 10,000 things to check,
yeah,
puzzles that need to be solved by colouring in. We reckon you can four colour this. We reckon you can do that. I kind of wish they'd just set it as a weekly newspaper puzzle. I know, obviously,
yeah.
when it solved them with computers or something,
Crowdsource
but
it.
weekly newspaper puzzle. And once we've finished, we've proved the thing. But we've got to solve all these puzzles.
Yeah, well, I mean, once they got it down to the 1,900, whatever. Because one thing also we take for granted, back in 1950, computers weren't big, so we couldn't just run it through a computer. Um, by 1975, we could, because we had fewer and computers were better. But even that, it still took about a month and a half for a computer to check all the cases. So a month and a half of
It's,
computing
it's
power,
quite a long
and that's
time.
like, yeah, especially as I do not trust myself to be as fast as a computer by like several orders of magnitude.
Yeah, yeah. People in chat are talking
Uh,
about other ways. They're surprised that computers are involved at all, I suppose. And people are asking other ways to prove it with graph theory, other ways to prove it with like algebraically, and people tried a lot of stuff, right?
yeah, so there are ways to prove six colors with graph theory fairly simply. Um, Basically saying that if you look at a single point, what can be attached to it, and then those different configurations, and then you can show that there'll always be a way. So we can graph theory definitely do six colors. Something called Kemp chains. If you want to learn more, it's KEMPE. Um, that's a way to see the graph theory proof for six colors, but this proof fails for four colors. There are intricacies that mean we can't do that for four colors. Um, and it's just annoying. All these intricacies basically mean that we have no proof for four colors beyond running it through a computer. Um, Someone interesting in the chat has said, do you think computer assisted proofs should be considered real proofs? I I'm in two minds of this one. I think yes, in the sense of we can now take this to be a fact. It's proof enough that we have proved it's true. However, I think it's very unsatisfying. I think it gives us no intuition about why it's true. I think it gives us no intuition about how to color in four colors. So I think it's all but useless for doing anything other than showing that we can color it in four colors. So it's proof at the very basic level. Like it proves the thing is true. Beyond that, it's very unsatisfactory, and I'm not a fan.
So that
Um,
used to be my opinion as well. So I can give a
Ooh.
contrasting opinion if you like.
Okay, yeah, please
Um,
do.
just that used to be my opinion too, right? That this is, yeah, it definitely counts. And then I found out about the Pentium bug that was discovered by finding Brune's constant. I don't know if you've heard
Mhm.
of this. I hadn't at all. I found out about it while researching a different episode of Maths Club, so
Or
spoilers,
someone
I
just
think.
linked it as well.
Ah, yeah. Me and chat. One
Oh
to
yeah.
1. Perfect. There you go. Wikipedia link in chat, and that means I can stop talking. Good. Right. Okay.
Right. Okay. So yes, I suppose computer proofs assume that the computer and the algorithm are efficient and correct. But is that not the same with any proof, that you assume that every logical step is correct, and that's why we peer review things? Mistakes can come in anywhere, and I think the basis of any proof is this is true providing there are no mistakes. So I don't necessarily know if you can disagree that this means computer proof isn't true by saying there could be mistakes, because you can say the same of any proof.
Well, I guess I don't really care if it's a computer. I guess I only really care if it's true.
I think
not.
that's a.
I only really care if it's this, if the theorem is true or not. And I think my current opinion has to be something like almost certainly. Which, yeah, sure, point taken. Maybe that's what I say about almost all maths. I think there was an approach.
I don't care beyond whether or not it's true though, because I think if we have a proof that's more constructive, then we can use it to either develop other proofs or other areas of math. Sometimes the result isn't the most useful thing. It's the methods developed in proving that result that can then be used for other results and other potentially more important things. So maybe if we did have a graph theory proof of this, that could then be used in other ways. I don't know.
I vaguely think, I'm trying to remember, I think someone might have done some work on proving this without computers semi-recently. If I can find a link to what I'm thinking of, I'll put it in the further reading notes. We put further reading notes in after the episode. I try to do them the day after the episode. Okay, that's the four-colour theorem, which feels like some people in the chat had seen. Should we switch it up?
Yeah, let's go to what's next. So if we skip forward a few slides now, because I've just spoken through it anyway. And we'll stop back there. Here we go. So these kind of problems are often called mutilated chessboard problems, but I think they're just quite fun anyway. So we've got a domino here, 2 squares, and we've got it's an 8x8 chessboard, but the 2 corners are removed. And a question comes, can we cover the chessboard with these tiles? If you want a kind of simpler version to play around with at home that doesn't involve drawing out 62 squares, you could try for a 6x6 chessboard, I suppose. I think any smaller than 6x6 and it will be fairly, you could do it by inspection. But yeah, question is, I mean, what's your intuition here, James? Do you think you can cover it?
I mean, 62's even. You've given me a 2x1 domino, so yeah, sure. Only one of them, right? I recently did. I don't want to brag. I recently did a minor bit of DIY around the house, so I now reckon I can achieve anything. 32 tiles. Let's go.
So with this as well, I will point out you can't break the tile in half. That would be the obvious solution, just split them up all into singles.
That was not what I was planning.
So you reckon you could do this? Okay. What if, just for the purpose of making it clearer and keeping your head straight, you were to mark every other square?
What does it mean to mark every other square? Sorry.
I mean, just so you can keep track. Maybe in the first square of the ground, you can put a little cross, and then in the second square of the ground, you can put a little cross.
Chat saying parity, which is a good example of something you can say that shows you know what you're talking about, but
doesn't give away
the answer to other people. Okay, so if I colour them in, I see. So this is a problem where the first time you see it, it's just a grid of squares.
Sure.
But then at some point you think about colouring in or marking every other square. If I was really brave, I would now have a go at that with pen, which has stopped working.
I was going to see if you were going to try and do that, or...
Yeah, the problem is I've set my cursor, because I selected that horrible yellow pen, my cursor is now yellow, so I can't see where I'm drawing.
Wonderful.
Brilliant, cool, right, okay.
There we go.
I think this is my mission.
Yeah, exactly.
And you said chessboard, right?
Yes, that's not an accident. Okay, we can stop here. I guess people are going to get the impression.
Okay.
Right. Does this help you now?
I guess
Yeah?
the thing that's helpful is that I suppose whenever I put this tile down, it's going to cover a white square and a black square. I've noticed that by doing this alternating pattern,
Yeah.
it's every other square,
Yes.
and that thing's always going to cover thing. I'm trying to work down to that corner because I'm trying to check what colour that corner's going to be. I guess the diagonal shows what colour that one's going to be.
That is, yeah, going to be very useful.
Because both the squares that have been removed are white squares.
Yes. So this does mean it's impossible because there are more black squares than white squares, but for the tile, it needs to cover one of each. Okay, so we've got this one. On the next slide, there's a more complicated example.
Oh, good. Okay. I like an
I
extension
thought
problem
I'd
on this
introduce
one.
it. Yes, here we go.
Ugh, oh no. Okay.
So I had to make it 3 tiles now because we're only removing one square. And obviously, 63 is not a multiple of 2. So,
Okay. So you've removed just one corner this time. 63 is
yeah.
multiple of 3. Can you cover the remaining 63 squares with that 3x1 tile?
Yeah.
I don't know if chat have seen this one before. I think we should let chat join
I think
in.
I know that the first one is used more than this one. So I think the question is it possible? And actually, this one is far more interesting than a previous example. Once we've got the result, we can talk a bit about why. But also, if chat want to have a think about, even if you don't know what the answer is, what you might do, how you might go about thinking about it. Got a few people saying they think they can't.
I'm always looking for reasoning or methods.
Yeah, some people have given some suggestions about what they think. A few people are repeating parity, but I don't think that's enough. There's
Ooh.
not enough for me to be convinced that that means you know the answer.
Someone says, can we rotate it? And I think, yes, you can rotate this tile, right?
Yes, you can
Otherwise,
rotate.
you're stuck because you have to put 3 here and then 3 here, and then you've got an awkward corner.
Yeah, we will allow rotation.
I suppose we were allowing rotation before. We never really drew anything.
Yeah, you could have had rotation before. It wouldn't have changed it.
Yeah, it's still impossible.
Yep.
Someone in chat has given me a method. The method is I tried it once, it didn't work, so it never works.
Cool. Does remind me of my favorite kind of proof, which is proof that this is proof by the fact this is a question in a maths exam. Because whenever you've got a maths exam, the fact that something has been asked as a question means that there's going to be an answer that you could solve within a decent amount of time, which sometimes eliminates certain possibilities just in and of itself.
Oh no. So what's the meta question then? Answer one of the 3. Yeah, okay, anyway. Can I use that idea as a question design element? 2 of them are fiendishly difficult and would be too long and unreasonable questions. The other one is doable. Interesting.
So, a few people in the chat have started to say we could use 3 colours.
Okay, I imagine they're imagining some sort of diagonal stripes.
Okay, yeah.
I want to start colouring in just to show them what they mean, but I'm worried. There's 2 ways to do it, right? Or maybe
there'll be
6 ways
mirror
to do it.
images. Yeah.
Uh,
But this is actually one of the interesting things about this. The colouring in doesn't fundamentally change any properties of anything. It's just labelling it. So it doesn't actually... You can pick one and it doesn't affect any properties of the thing. So it doesn't actually matter really what you pick.
Well, let me think about... I think I'm worried about... Maybe this doesn't matter, you're right. But the thing I'm worried about as I start to colour it in is whether I do stripes this way.
Okay.
Or stripes the other way, like a 90-degree rotation.
Yeah.
And those don't feel the same to me because if I do a 90-degree rotation, then of course the square that's missing is different now.
I mean, why don't we pick
So
away and try?
I'll pick away and try, okay? And if it matters, I hope I don't get the wrong one. Come on, PowerPoint, you can do it. Okay, what are the three most tasteful colours here? Probably, and suitable for colour blindness. I'm going to go red as a starting point.
Red, purple and white, maybe?
Red, purple and white. White is a very clever choice. I would not have thought of that. But
I would choose white for one of them. This will save you a lot of work, James.
This is why we get Sophie on the stream. My art skills would have been red, green, and dark brown, and I'd have been in big trouble.
Oh, that would have been worse for colour blindness, putting red and green.
Yeah, I think the worst for everyone.
Yeah.
Sophie, I'm focusing so hard on counting to 3 right now, you wouldn't believe.
Yeah, I will fill with fun facts about life and yeah, while James is counting to 3, what can I say? I am doing a PhD, this is true.
What's your PhD?
I'm doing it
I'm
doing it in number theory. So basically prime numbers, which are very fun. I'm early days, so I did my undergraduate degree, took a few years off, 1 year because I was ill, 1 year because I started working in finance and then realised I hate it. Personal preferences. I have many good friends who work in finance and nothing against it. But then I went back and did a master's and did a PhD. So it's been good fun. I'm really enjoying the PhD actually. I think it's nice to just get to do maths and that to be a thing, and you don't have to worry about jobs or, I mean you do because you still have to worry about paying rent. But on the whole, I think for me all I really want to do is maths, and it enables me to do that. So good. Right. Are you happy with your colouring, James?
Not yet. I'm doing cross-hatching so that they're different textures for people who can detect textures but not colours.
Smart. So someone says, what kind of things about prime numbers? Because it doesn't narrow it down much for number theory. This is true. And actually, to some extent, number theory is a lot more than prime numbers. But for me, I'm looking at structure within sets of prime numbers. So in that case, I am particularly looking at certain properties that you can apply to sequences and when they are and aren't random. And James needs to cross-hatch the missing square as well. And in terms of what I didn't enjoy about finance, there are various things, capitalism, and I just didn't believe in it. And I can do stress, but not if I don't believe in what I'm doing it for. So it just seemed not worth it to me. Right, here we are.
I've coloured in the squares.
Coloured in the squares.
Chat telling me what to do next?
Chat wants to know about my life.
Okay. So I guess the idea of colouring in with 3 colours was that this tile always covers one of each colour. Is that true?
Yep.
Vertical, horizontal?
Yep.
Yeah, I'm looking at some sets of 3 to check, and I think it's true that it always covers. Maybe not in this order.
No,
Maybe
exactly.
not blues in the middle.
6 different orders it could be in. But, well, I guess 6 if you count the vertical.
Yeah.
Everyone's now saying how many flags they can spot, because obviously red, white and blue is France and Luxembourg and the Netherlands. And fun fact actually, Netherlands was where I did my finance job. So
that is a fun fact. Imo wants us to count the squares that have the different colours, and I guess what they're imagining is, it's tricky, isn't it? If they were the same, if we get the same number for each of the colours, then that's really annoying. But we should count them, I guess.
We should count them and see. Again, this is a bit like proof of is by the fact it's in a maths paper. I think there's an element of proof by the fact I let you spend 5 minutes doing this, James, that it might be helpful.
I've counted the red squares. There are terrifyingly 21 of them, which is like the worst possible thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I've got 21 blue squares as well. This is pretty scary stuff. Am I wrong?
So,
I can't count.
Doing a quick one, on the diagonal there'll be 8, and then there are plus 2 times 5 plus 2 times 4. So 8 plus, 2 times 2. Yeah, there are 2 diagonals with 5 on, 2 diagonals with 2 on, and an 8 down the middle. So 8 plus 10 is 18, plus 4 is 22.
Minus
But then
this
we're
one that's not
subtracting
there.
minus the one that's not there. So that is 21.
And white and red
So-
are symmetric opposites of each other.
Yes.
So,
Actually, even just by the fact that white and red are symmetric, we could have determined that white and red would have the same. So that gives blue. So this one, they are all 21,
yeah, okay.
which is interesting. Now, I'll tell you, if you do it the other way, you don't get the same number.
Yeah, I've thought of a way to pivot as well.
I mean, a quick way to see that actually is consider removing a different square.
Yes.
Yeah.
So it's easy to give up, having done all the counting, and said, oh no, there are 21 of each colour.
Yeah.
Maybe this is possible. To
Yeah.
say, oh, if I coloured the other way, or if I put this one back in again
Yeah.
and remove that one,
Exactly.
then I've got the same problem.
Yes.
This one's now reunited. I've got the same problem, but instead of removing a blue square, I've now removed a
Yeah.
white square.
And now they aren't all the same.
Yeah, so now white goes down to 20 and blue goes up to 22. I guess in the original chessboard, they were out of balance. Out of balance, and it was only removing, if you remove the correct corner, then it looks possible.
Yes. Also, on the original chessboard, if you swapped, you just swapped black for white and it kind of didn't matter. And also, on the original chessboard, it is the case that if you remove 2 of the same colour from anywhere, you can't do it, but 1 of each colour from anywhere you can.
Oh,
But it takes other maths to prove that. And that would be more of a graph theory question that you can prove it with. But yeah, this kind of shows that you can't just assume same colours mean you can. It's one of those converse of the theorem isn't necessarily true.
yeah. In particular here, it would, if that way of thinking worked, that
Yeah.
if the colours match up, then maybe it's possible. If the colours don't match up, it's not. If that way of thinking worked, then you'd be in the situation where removing one of the corners meant it was possible, and removing a different corner meant it was impossible. But the 4 corners are all the same. The
Yeah.
colouring's not real. That's just my doodling on top of the slide. Okay.
So this, yeah, it's a lot more interesting with 3 because of this reason. Also because there are places where you could remove 1 square that would make it possible.
Right. Let's ask chat to see how much of the stuff just now they followed.
Yes, that was a lot of what ifs and changes and things.
Let's say you have to remove a square. So Sophie says maybe this is possible, but even if we're not sure, so it says you can remove a square and then cover the rest of it by 3x1 dominoes.
Yeah.
And hard question, I suppose, which square should we remove? We've seen that removing this blue square in the corner. No, we've seen removing any of the corner squares.
Yeah.
We've seen that removing any of the corner squares is bad, because once you've removed a corner square, your worst enemy could come and colour in the other squares such that they're out of balance.
Now, the fun thing about this as well is I can't remember which square you have to remove. And it could be that I'm misremembering. So this is a thing even I don't know. We can discover this together.
We've introduced an element of danger to the live stream, which is fun.
Yeah.
Let's wait for chat to have a go. So the question is, which squares can we remove? See, the extreme
don't
corners,
think
they're
it-
way out.
Is true for certain. If you allow L shapes, you're fine.
Yes. That's interesting, because the L shapes could cover 2 of the same colour, right?
Yes.
I've seen that as a separate question.
Yeah.
I think
But-
I've got an opinion on which square you could remove and stand a chance of covering the thing. Luckily, chat's here as well, an anonymous person. Yes, anonymous has said the 2. Chat have said the 2 things that I was hoping they would say.
Yes.
I'll do Imo's first. Imo says it would have to be blue. Yes, because
Yeah.
on the original chessboard, or this width, it's no longer a chessboard now. I've coloured it in weird. You've got to remove a blue square so that you end up with things in balance. If you're going to cover it with, what are these called? Three squared dominoes.
Trominos.
Trominos. Okay.
Yeah.
You're going to cover the rest with trominos. You've got to remove a blue square, and more than that. Yeah, because it would have to be
rotating to the same colour.
It would also have to be a blue square if we coloured it in the other way round.
Yes.
So that leaves only these squares.
Yes, and mirror images of. Yeah, exactly.
Yes. I guess there's quite a few ways to colour it in, but the important ones are blue down this diagonal and blue down that diagonal.
Yeah.
So if you remove one of these,
I think it would then be possible.
I think I'm at maybe. Once again, you're at yes, I'm at maybe. If you remove one of the
I'm
others,
also at maybe actually, because I'm just trying to quickly do it in my head and I'm getting somewhere.
So what sort of thing to be clear, what sort of thing are you imagining for when you're imagining how to cover it with trominos?
If you look at, say, let's pick one which we're removing first to make it.
Oh yeah, sure. Okay, I should not really have four that I'm removing. This one is now gone.
Okay, so if we look above it, the two squares above it, they can't be part of a vertical, so they're going to have to be part of a horizontal.
Yes.
So let's suppose that they are horizontal going from the far edge.
Okay, let's give it a go. I don't really have a take-back mechanism on this particular whiteboard, but let's go.
So we'll go for it. Right, so this now means that if you look at then the two to the left of this square, they have to be vertical. They can't be part of a horizontal. And that is already now locked in.
Okay, and then some more.
Yeah.
And then some more. There's consequences.
Yeah, exactly.
Consequences.
Don't forget though that the other four aren't missing. Only the one.
Oh yeah, true. I got a bit carried away. Now I'm going to give it a go like this.
But this will
chat
work.
has described a way that yeah.
This will work going round because then next to our shaded out we've got 3 straight there.
Yep.
Below it we've got 3, and then we've got a 3x3 grid, which.
Choices.
There we go. So this does work. This is my second favourite kind of proof, which is proof by doing it.
Around the board.
So yes.
Come on, whiteboard, we can do it. Proof by doing it. Trademarks.
So this one is possible.
Excellent. Okay. This makes me think about how you could extend this to different sized shapes and different sized grids. I'd be really interested to find a case where you might think that you could remove a square based on these kind of parity or 3 parity arguments, but which actually, if you try to do this like tessellation puzzle, it doesn't work for some other reason. I don't know if that sort of puzzle exists, but I'd really like a version if someone says, "Oh, consider tiling a 7x7 grid with 5x1 dominoes or something." But which squares are you going to remove?
That's true.
I think I'd quite enjoy that version of the puzzle where you get to the last step we just did and then fail, not before.
Yes.
The L shapes thing that you mentioned in passing.
I think I'll let you people try that out themselves. Actually.
Okay, so homework is to try and tile parts of the chessboard using these shapes.
Yes.
Those are squares.
Exactly. I think this brings me on to kind of my final thing I wanted to talk to you about today.
Okay.
Hopefully is on the next slide. We'll see. Yes, because one of them is a 1 domino. We've got dominoes. We've got 2 of these trominos, but we can keep going. So, what about 4? But how many are there?
Wait, are we going to play Tetris at some point here?
Well, this actually Tetris does come from like tetra, which is Greek for 4. They're called tetrominos, and then tennis is where Tetris comes. But yeah, how many ways of doing 4 are there? And also, I think one thing you have to define clearly: rotations and reflections will say the same.
Oh, okay. So these ones.
Yeah, we'll say that they're the same for this purpose.
Um, that's an equal sign, and these are bunny air quotes for we're saying these are equal to. Okay, so is it easy to work out how many of these there are? What sort of methods can we use to? I'm sort of just drawing random Tetris shapes I remember. I don't think I've ever really
Yeah,
thought about how many there are, or how I would do that systematically.
yep. And we count those as the same.
Right, okay, because they're mirror images of each other.
So someone has said that there are 7. There might be 7 in Tetris, but that's counting some as the mirror images as distinct. But
Why does
I'm
Tetris
going,
contain mirror images of the pieces?
yeah, I know, despicable. Well, I guess in 2D Tetris you can rotate them round. If you were to play like 3D, you could probably flip them. Because obviously mirroring is just rotating around the z-axis.
I'm at 5 and I've got a bit stuck. I wonder if Herb saying 7 is counting the 2 pairs
It
separately.
is. It is.
Okay.
So these are the only 5.
Right. Are these the ones with names that are like letters of the alphabet?
Oh,
Or
I don't know. They can be, but actually pentominoes are the ones really with the names there.
pentominoes have got names. Okay.
So pentominoes have 5 squares. Do you want to try and see in the last 8 minutes how many
Okay.
pentominoes we can come up with? Because the cool thing about this, whilst you're having a think,
Okay.
is once you get to 8, maybe 7, you have to decide, do you count ones with holes in them? Because for 8, you could have like a 3x3 grid and remove the middle one. So you're going to have to decide, does that count or not? And then no one knows an expression for how many n-ominoes there are, regardless of what definition. I've read papers where people have managed to bound it, and they've said, oh, it's less than this function of n. But we don't have an exact formula for this yet.
It looks like it's quite a lot. He says,
Yes.
drawing pentominoes.
Yeah, so the ones you've got so far, you've got, if you turn your head sideways, you can see you've got an S, a T.
Wait, what?
Um,
Which one's S? Oh,
S
that
is,
way.
yeah, that's the T, that's the S.
They've got
I
letters.
suppose the one before that, C or a U, depending on what you want. There's
I
obviously
checked whether I
L.
was spelling anything along the way. L.
Yeah, you got to be careful.
I spelled locust.
Oh, so close. The one that you finally drew, I think sometimes referred to as an F, but it's very much
It's an
debatable.
F with the arms on opposite sides.
Yeah, it's kind of an F if someone's got lazy and hasn't fully crossed through it and just stopped partway through.
Do you know what I'm really surprised by? Is the news that I've drawn all of them sideways. You wouldn't think that's possible, but okay. I guess does this one come in pairs? Hang on, yeah, this one's got like a.
I suppose you could say the pairs of, yes, yeah, there are going to be rotations and things.
Yeah, I've got flipped over L's to contend with in here.
Yeah. Someone in the chat's surprised that there's no formula. Yeah, I know, it is really surprising, but have a go at it and you'll quickly come across some issues. There's things like, oh, you could say, you could put it on a grid axis and say, let's 0, 0 be the like furthest left and furthest south point or whatever. But you can't say that because if it's the furthest left point, it doesn't mean it's necessarily the furthest south point. Using left and south, commonly directions used in conjunction with each other. If only there were some other thing like south that meant left.
Oh, right, I've missed a really interesting one, right? The kind of X-shaped one, right?
Yes,
that
X.
you can't.
Yeah.
If you put it in the positive quadrant, it
Yeah.
doesn't
Have
touch
a-
the origin, which you might expect
exactly.
if you're trying to like grow them in the lab from the origin, one square at a time.
Yeah.
That one.
Then you're either going to have to go into negative space or. Yeah, how many have you got here if we're not counting reflections and rotations?
Not counting reflections and rotations, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, there are 3 more, I'll tell you.
3 more. I'm nowhere near done.
I'm trying to work out. Oh, yeah. Yeah, there are some nice ones. Um, think of the L and how you can make that more L-like.
Oh gosh. Yeah, so I was growing off I had a spine of length 3. People who check might have seen my system here,
Mm.
which let me down a bit. X should have been next. Yeah, so spine length 3, I could grow 2 off the same point.
Yeah.
And if I grow 2 off the same point over here, I'll get T. If I grow 2 off my spine over there, I'll get a kind of rotation of that one.
Yeah.
So I'm losing interest in growing 2 on the same point.
What if you took the one between L and C and moved the final square? You get one more that way.
Isn't this one a reflection of the one? Am I being an idiot?
By the final square, sorry, I meant the rightmost square.
Oh no. I genuinely can't see anywhere else to put it. I'm being fake.
Someone in chat says, surely there are many other methods of proof that don't include origin. There are other attempts, but none have yet worked. Like, my kind of counter to that is, sure, find one that works. It is harder than it seems. Yeah, so the one you're missing, consider moving the rightmost square of the one you've just circled up.
Oh no. Oh, I don't like that one at all.
Yeah, it's like a little worm.
Oh, I don't. I'm sorry. I mean, they're all lovely and brilliant in their own unique way, but this one's not good. With my system of most of them look like a long straight line with bits coming off it. That system's really not going well for me.
Oh, you're gonna hate the final one then. It's a W.
Okay. If you're playing along at home and you've got 12 pentominoes counting reflections and rotations of the same thing, then well done you. Don't be mean to the dark, says Urban Chat.
The dark. Is that what we're calling it? Brilliant.
We are
How
now.
How
Good. Lovely stuff. As
Right.
always. That reminds me of, by the way, of a problem which you might know, which is how many nets are there for a cube?
Ooh, that's a nice one.
It's the sort of problem that sounds easy, but is not as easy as it maybe should be.
Yeah.
So I guess it's a subset of the hexominoes, things made of
Yes.
6 squares that are connected together, but only some of the hexominoes fold up to give you a cube.
Yes.
So then extension, what do the other ones do if you fold them up?
Some of them, I guess, would go in on themselves.
Yeah, I
What do
guess.
you think about the pentominoes? If you take one copy of each and allow rotating and reflecting, you can make a rectangle.
Ooh. You can fit them all together into a nice
Yeah.
gift set box. Oh,
Yeah,
including both
it's
my
not
L's
a
and both
flat
my
piece
whatever.
of paper. It's more like a placemat, isn't it? But
Oh, okay. You can fit them all together. Now there is in any sense that I've offended a dark, I'm not getting invited to any UKMT summer schools anymore, because ducks play an important role in. I
I'm
think
trying to
maybe
remember,
just
'cause I went to a summer school as well when I was 15 and 16 actually. I went to 2, not to show
I
off.
think at some
Yeah.
point since then they've introduced some ducks.
I was gonna say ducks were after my time.
Yeah, sad
Yeah.
duck.
There we go. What a note to finish this
What a
on.
note to finish, yeah, indeed. Sophie, thanks for coming on the show and
Yeah,
showing us
thank you for
problems that
having
are
me. It's been very fun.
improved by a splash of colour. I just talked right over you, I'm so sorry. Let me give you a chance to do some self-promotion. Where can people find more of what you're up to?
This is a good question. Where would people find more of what I'm up to? I hate self-promotion. Given that, probably it's not a surprise I didn't last long in finance. But I suppose I have a website. It's a WordPress website, Sophie the Mathmate. If you Google Sophie McLean, most of the first few things that come up are me. Please don't stalk me. But I do have a Twitter that's public, at Sophie Mac Maths. And the other thing I'd say is check out Chalk Dust. So Chalk Dust is a magazine. It's free. You can get a physical copy for the price of postage, or you can download a PDF. We publish twice a year, and it's just fun maths articles and puzzles and things. So it's kind of designed at roughly, we say first year undergrad-ish, but what that means is some things might be more advanced, some things might be more simple. So I'm sure everyone here will be able to understand at least some of it.
It has a recent issue featured a which integral are you flowchart test, which
That's the fun.
I think is appropriate for all ages if you're.
Absolutely.
Okay, thank you very much, Sophie. If you want to find out more about the Oxford Online Maths Club, we've got a website too at sorry, let me read out the website one more time. www.maths.ox.ac.uk/r/club. The link is on the screen and in the YouTube description. We try to put up further reading notes. I'm going to write something about L-shaped tromonos and possibly Kemp chains and the six-colour theorem in the further reading notes this week. We try to put those up on Friday. I'm saying this on the stream to try and hold myself to a deadline. Very quickly, what's your favourite colour, Sophie?
My favourite colour? Oh, blue.
Yeah, I was going to pick blue as well, I'm afraid. Shade of blue?
Navy.
Cornflower. Right, okay. On that, we'll be back in 167 hours for another episode of the Oxford Online Maths Club with more special guests for the next few weeks. Thank you very much, Sophie, for being the first in a series now of special guests. No, our previous guests are special as well. What am I saying? Back to back, we've got lots of special guests all term. Okay, before I say anything stupid, let's wrap up. Take care, everyone. Have a great evening, and I'll see you next week. Bye.